Hello guys, today we are going through improper integrals application and improper integral type 2. I don't think I'm gonna actually cover application questions like these because this is just set up. You guys can see the annotated versions on our lecture. There's not really much to explain. It's just how to set it up. And you could just see the example, read the text, and understand. Same with these examples. If you go watch the last lecture I posted, it explains how to do these. Same concept, just a couple more steps. So nothing different really. What I'm trying to do by these YouTube lectures is that show you the actual important stuff. The practice is on your own. I'm here to just show you what's different and the ways you could do it that you don't know how to do, right? But if you watch last lecture, you should be able to do these. That's why I'm not going through them. I'm just trying to explain new concepts. All right, so this is a recall. I'm not going to cover this. All right, so improper integrals type 2. What is type 2? So if I have a function, actually, we'll use this as an example because it's a good example. So if I'm integrating from 1 to -1, and I have 1 over x squared. When I integrate this, when I do, let's say, okay, so let's actually integrate this. So what I'll get is x to the -2, then I'll get x to the -1 divided by -1. So it's x -1 over x. That's my integral, right? That's just quickly, so let me rewrite it. And so dx integrates as -1 over x from 1 to -1. All right. And so the thing is, right here, when I take the integral, when I say -1 over 1, so I'm taking the top integral, minus -1 over -1, right? So it's this minus this integral. And I'm just going to simplify here. -1 plus 1 over -1 is just, why do I have two negatives here? Oh, okay, so these cancel out. So this actually stays as a minus. I see. Minus 1, right? And obviously, I will get a -2 like they did above. But the thing is, you see, between these bounds, these bounds are from x at -1 to x at 1. And so when you integrate, you're taking all the space. Let's say this is the curve. You're taking all the space under the curve. But we know at 0, 1 divided by 0 is indefinite. So this has to have an asymptote in the middle right here at 0. And so the thing is, so how do I integrate this? Because obviously I gotta, take care of this space in the middle. And you see, this is the actual graph for this integral. And there is space right here. This is the space that I have to consider. I can't really take the integral of this because it doesn't exist. And so that is the type 2. So what type 2 says is either if A or B, so let me draw better, either if B or A cannot be integrated, for example, like this, or some value in between, which is the example we had, like -1 and 1 can be integrated, they're fine. But there's a value in between where it's indefinite. So it says if the function is discontinuous at B, or discontinuous at A, or discontinuous at a point between A and B, like we had the 0, then this is an improper type 2. And remember, the type 1 was either infinity to some number, or -infinity to some number, or infinity to -infinity. This is type 1. And when you have it like numbers, not infinities, but it's continuous somewhere on these numbers, this would be your type 2. All right. So the question is, well, okay, how do you deal with type 2 integrals? And so the way you can deal with type 2 integrals is by taking the limit like we did earlier with type 1. But instead of infinity, you're going to take the limit of the integral that you can't really integrate because it's infinite. Oh, sorry, not infinite, where it's asymptote. So right here, if we were to take this, so we have from 1 to 0, 1 over root 1 minus x squared, right? We know that if x becomes 1, right, which is this bound, if we put 1 for x, then this would be 1 minus 1, which is 0, root 0, 0, and then now we have an indefinite integral. which is not allowed. And so how can we take this? Is we take the limit to 1, right? So if we were to integrate this, and they give you the integral up here, so nice of them. And so we're going to take the limit as w approaches 1. Remember how before we couldn't take infinity? So we took the limit of infinity right here. We can't take 1 as a bound because obviously it makes the whole thing go to 0. So we're going to take the limit to 1, but not including 1, right? So we're taking it all the way up to like 0.9999. And you're like, okay, well, why is this 0.999 instead of like 1.00001, right? This, I'm taking it from the left of 1. This, I'm taking it from the right of 1, because this is my 1, right? And then very close to it, this would be 0.999. This would be 1.0001, right? And so how do you decide whether you're taking it from the left or the right? And you have to have some knowledge of the graph, but to be honest, not really, because what you're doing is, you see, because my bound of 1 I can't take, so I now have to take from 0 all the way to 1, but not including 1. So from 0, 0.1, 0.234 until 0.999, but not including 1. And that's how I know 0, 1, I'm taking it from 0 all the way, 0.999, and that's to the left of 1. And that's how we know we're taking it from the left side of 1, right? And then now we have our sine negative 1x. We don't have plus c because there's bounds. Let me just rewrite this a more pretty way. So sine negative 1x from w, from 0 to w. All right. And now if we take the limit, so what we're going to say is sine, so we're going to say the limit. Thing is, when I zoom in, I write better, I feel. I'm to my screen. Hello? Okay. So the limit, I don't know why it looks like that when I zoom in though. 1 from the left of sine at w, sine inverse of w, minus my sine inverse of 0. Okay? And so when I go down here, I know as my w goes to 1, when I do sine inverse of 1, what will I get? If you just plug into your calculator, you put 1 in here, and you plug into the calculator, you'll get pi over 2. And sine inverse of 0 is just 0. And so we know this converges, right? Converges. And so that's honestly how you do it. It's the same as the infinite. You just got to take the point now. Instead of this being infinite, you take the point, and you just got to, you want to identify whether it's from the left or right. So let's see, this example is pretty similar, but we'll go through it because it is a divergent, it diverges. And so I want to show you guys a diverging example. And so now when we take this and we integrate, this is a linear, so we can use our ln, right? The integral of anything, a fraction over a linear function, is a ln absolute of that function at the bottom. And so now what we'll have is the integral from 0 to 1. Actually, I'll just write the integrated form, which is ln absolute x minus 1 and plus c, right? But then we have our bounds. So let's take our bounds. We'll say the integral from 1 to 0 of 1 over x minus 1 dx equals to my limit. And now you're going to think, well, why is this guy taking the limit again? Okay, so you see, if I put my 1 on my x, 1 minus 1 is 0, goes to 0, that's not good. So let's take the limit. We're going to take the limit of 1, because this technically goes from 0 to 1. And so my 1 is going to become w, so w. And now the question is, well, where am I taking the limit up to? Is it from the left of 1? Or is it from the right side of 1? And obviously, we see our graph. So if we go here, and we have 0 to 1, we're going from the left of 1, because this is, we're going all the way up to close to 1, but not 1. And so this is the left of 1. And so 1 from the left. Then we're going to say ln, and then we're going to take the limit, which is going to be my w minus 1. And then we're going to say minus my ln of 0 minus 1. And as you can see, when I sub these numbers in, I'll get ln of something very small, close to 1, but not 1, minus 1. And I will get a ln negative 1. And obviously, I'm here doing an absolute, right? And so when I do the absolute, ln of negative 1 is just 0, because this is ln of 1. So this right here goes to 0. But the problem is this one. This one will always give me a negative number, because 0.999 minus 1 is a negative number. And so you could also say, if I plug my 1 in, 1 minus 1 is 0, which is also indefinite. So it's the same issue, really. So you don't even have to put 0.999. You can just say, take the limit at 1. And so what this will give you is indefinite. And if you go and, but this is not DNE. This goes to negative infinity. And how do we know this? Because if you have some knowledge about your long graphs, they go something like this, right? And we're taking, this is ln at 0, which is as ln approaches 0, it goes to negative infinity. And that's how we know this goes to negative infinity. But the answer is still the same. It diverges, right? And so that's really how you do these type of questions. I'm gonna leave the rest of the questions here for your practice, and since you already have the answers on the lecture, you should be fine for them. But for this specific example right here, I'm gonna do, just since this is, we haven't done it because right now we've been doing the bounds, and now we're gonna do one where it's within the bounds. We do know from negative 1 to 1, we're gonna hit 0. And if x becomes 0, it's divergent. Or not divergent, but there's an asymptote. So what can we do here is you have to split it. You have to split it at the point that it's going to cause an issue. And so if you rewrite this, I can say from 0 to 1, or actually, I'll write it in decreasing order. So from negative 1 to 0. Oh my god, no. All right, we'll go with this one. X squared, right? And then we're going to say plus the integral from 0 to 1 of 1 over x squared. Now, if I take this and I integrate, what do I get? So here on the side, I'll integrate it. 1 over x squared dx. You get x to the negative 2, and then you get x to the negative 1, and yeah, you get negative 1 over x plus c. There you go. All right. And so that is my integral. And so now when I do this, I can say this equals 2. Because I want 0 is where, it goes wrong, I'll have to take the limit. So I'll say limit as w goes to 0. And you see from here, this is my 0, and this is my negative 1, this is my 1. From negative 1 to 0, I'm taking it from the left. All right? And so I'm taking it from the left of my negative 1 over x. And then I'm going to say plus. And now I'm going to take another limit. I shall keep it in black. I'll take another limit because now I'm going from 0 to 1. So this limit is going to be not the same letter. You have to choose a different letter because we're taking it from the right this time. And so in the lecture, I know she used r, so I'm going to keep it consistent. 0, and you see now I'm on the right side of 0 because I'm going from 0 to 1. And so this is going to be the right side of negative 1 over x. All right? And obviously, now you want to start taking your limits. But I did forget one crucial part, and that's right here. You're still going from negative 1 to w, and here you're going from r to 1, right? And so I'm going to rewrite this here, and I'm a little bit clearer. And so we have our integral from negative 1 to 1 of 1 over x squared dx equals my integral from negative 1 to 0, and we have 1 over x squared dx plus my 0 to 1, 1 over x squared dx, right? Which equals to the limit of w to 0 from the left of my negative 1 over x between negative 1 and w plus my limit as r goes to 0 from the right of negative 1 over x from R to 1. Okay? And now, when I take this and take the limit, so down here, I'll have the limit as W approaches 0 from the left, 1 over, and then you'd sub in your limit, so it'd be 0, minus 1 over negative 1, right? And so, well, it would be minus minus, right? Because, so here, let me rewrite this. And so this would be a minus. When you take the integral, it would be one integral minus the other. One bound minus the other. So one bound minus the second bound, which is, this is a negative 1 over x. So negative, so this is one bound, minus our second bound, which is negative 1, over my bound, which is negative 1. And so this whole thing goes to positive, and this stays negative. And so what I'll get here is negative 1 over 0 minus 1. All right, and the right syntax for this is actually just put w, because you're taking the limit to w and not 0. I just put it at 0 so you know what's actually going on. We're just going to 0. All right, but I guess mathematically this would be the right thing to say, because it's w going to 0. Okay, and so where does this go? And we know from earlier, you remember the graph, or if you scroll up, you'll see the graph goes, I believe, something like this. And so we know as we're approaching 0 from the left, we're going to positive infinity. And so we know this goes to positive infinity, right? But obviously, we do have that negative 1 or minus 1. And so we'll keep that right there for now. And then the next step here would be, we're going to go, and we're going to take our second limit, which is this part. Right, don't forget this. So this would be now plus this limit. When I sub in my r, it's the same. It would be the same thing. It would go to infinity, right? But obviously first it goes to 1. So we're gonna say negative 1 over 1 minus, and then we have negative 1 over r. And obviously this also goes to infinity. And now what we're basically saying, if I simplify this, what I'm saying is I'm doing infinity minus 1 plus, well, this would be still minus because of 1 over 1. So minus 1 minus, and there's a negative, so it would be like plus infinity, right? And so minus 1 and minus 1, this is the same thing as saying equals infinity plus infinity minus 2. And as you can see, infinity plus infinity minus 2 is just infinity, and so we say this goes to infinity and it diverges. And that's how you do it when there's you have the asymptote in between the bounds at some point c. And so you split it into two integrals, from negative 1 to the point, and then from the point to the bound, and then you take the limit for both, and you go from there. And so right here now we have which of the following integrals is improper. This is very good practice. And so we know here when we sub in our infinity into our cos to the negative 7, this would be improper. And also, you don't have to even think about it that way, is that if there's a negative, this is a type 1. If there's a negative at the top, negative at the bottom, or if it goes from negative infinity to an infinity, if there's an infinity at the top, infinity at the bottom, or from negative infinity to infinity, that would always be type 1 improper. Right here is this. So it is when your denominator becomes 0, right? And so when can our denominator become 0? The only way we can make our denominator become 0 is if we have a negative 3. But this is squared, so this will never be negative 3. Therefore, this is not improper. We look here, denominator again. Can we ever have this as 0? How? Only if we sub in 0. And obviously this is from 2 and 3, so it'll never be 0. Here, can we ever make this 0? If I plug in my negative 4 here, this would turn into 0, and then root of 0, and this would be improper, right? And so you'd want to take your limit to the negative 4, from negative 4 to 10. All right, this is not on, so I'm not going to really cover it. Applications. Now we're going through arc length. There isn't really much for me to explain when it comes to arc length. because most of it is just subbing into the equation. So this section you can kind of just yeah, you just to be honest, you just sub into this equation. So they'll give you some function and they'll tell you find me the arc length. And obviously if I have some arc like material, let's have this is metal. All right? And I'm trying to find the arc length here. Then the way you can think about it is, you see it says the derivative is continuous from A to B. And it's like, well, if I'm doing arc length, then like no shit it has to be continuous. How am I gonna find the arc length if I had like, you know, from here and then it cuts off and it goes here? It's like, well, then you'll take from A to B and then from B to C. And that's how you can combine both arc lengths, right? And that is the same thing we were going earlier when we had it go like this. And so we split the integral into two parts and we took it from here to here plus from here to here. And that is basically the same idea, right? And that's why it says it has to be continuous when you sub into this equation. And this equation basically said, this is a given equation. All you got to do is take your function, derive it, and then square root the derivative format. That's really it. So here, I think she gave you guys some function here that you have to do. So same thing, even for your surface area, same thing. Here, we do have this. I'll set it up real quick. And so what are these looking? Find the surface area. Surface area. This is a given formula. So surface area equals, what's my bounds? It's saying from 0 to 2. Like this doesn't get any harder. From 0 to 2. And then it says 2 pi. Y, what's my y? 1 over 3 x cubed. Right? That's my y. And now it's asking, okay, root 1 plus the derivative. So if we take this and we derive it, 1 over 3 x to the 3, you minus 1, it becomes 1 over 3 x to the 2. Then you divide, or you bring that 2 down, right? And so you multiply by it. And so it's become 2 over, oh, I think actually I messed that up. Oops. And so 3 comes down actually, so 3 over 3 x to the 2. That's what it's supposed to look like, and this would go to 1. And so x squared, and so that's x squared. And then obviously it's squared, the derivative is squared, so we're going to square the derivative. And then root it, dx. That's about it. You integrate now, you get your bounds, you sub them in, you're done. And so that really is what arc length and all that is, just formulas and you sub in.